In this segment, we're going to think about the learning objective, describe examples of person, place and time variables, and discuss the contribution of person, place and time studies to public health. Historically, epidemiological investigations have been thought of in terms of an epidemiological triad composed of 3 groups of factors. So we're going to think about the use of this sort of model in public health investigations. So particularly in infectious disease epidemiology, when we're looking at an investigation concerning an infectious disease, then the epidemiological triad is a model that recognizes 3 major factors explaining the propagation of infectious diseases. These are the agent, the host, and the environment, and then optionally sometimes there can be a 4th factor, the vector. And so here's a picture of the epidemiological triad with the attributes of these factors listed to give an idea of how they might be useful. So if we're thinking about an infectious disease, then there's the agent itself, which might be influenza, it might be SARS, it might be tuberculosis, it might be malaria, it might be dengue fever. And so each of those infectious diseases have a different level of infectivity. Some spread very fast, some spread quite slowly and are quite difficult to catch. Some are much more serious than others. And some have different effects on the host in terms of their immune response. There's also a number of factors which might determine the host's response, the host's own attributes. So the person's age, your immune system, as you know, acts differently in younger people than it does in older people. Sex, the immune system acts differently there slightly. Genotype could make a difference, nutritional status, health status, all the things that might affect how a person responds to an infectious disease. And then there may be other factors which affect how it spreads, environmental factors, the weather. Some diseases spread better in cool climates than in warm climates, or depending on the humidity, housing, occupational setting. Maybe an infection might spread more easily within a hospital, or more exposure to infections will be there. Air quality can make a difference, and food and water might include some pathogens. And for some infections there may also be a vector that's important. Say for example like malaria, then the vector is the mosquito. The same with dengue fever, where the mosquito carries the infection from person to person. So these can be laid out in a triangle to help you think of what might be causing an infectious disease outbreak. And so here's an example of a very famous example of an infectious disease investigation which took place in London in 1854 when John Snow was investigating an outbreak of cholera. So there's the cholera agent, a picture of it on the left hand side. Then the water supply was the host for the cholera, because the cholera they had discovered was spread by the water, and the environment was determining the use of different water supplies, because at that time in London there was lots of different water companies, and one of them was, and the water pump was supplying water polluted with cholera. So by very careful mapping of who had cholera, John Snow was able to identify the water supply as the cause of cholera, which then engendered a whole sanitation revolution. And there's still that pump on show in London, the pump from which the cholera came, and by closing the pump, the epidemic was stopped. So in those circumstances, thinking about the factors as coming from three possible sources was a useful way of understanding the problem, and it was seen as a big breakthrough in the use of epidemiology to improve public health, particularly as it was followed by this immense effort in many places to ensure that the water supply was free from any contamination and any infections. So the same structure can also be used to think about the three key factors that may determine chronic diseases. So we have the person who, and they too have their attributes, age, sex, ethnicity, socioeconomic position. We have the place, which highlights where they are in global places. Is it a local issue? Is it urban versus rural? Is it clustered in one place, or is it everywhere? And time focuses on attributes such as a secular trend. Is it changing? Is the incidence of disease changing over time? A lot of chronic diseases, the incidence has changed over time. For example, in the 20th century, there was a sort of epidemic of cardiovascular disease in some countries towards the latter half of the 20th century, which has been falling off. It can be just at one particular time. There might be some sort of temporal clustering, or maybe it comes and goes in some sort of cyclic fluctuation. All of these things might be informative about what's causing the disease and how to prevent it. I think the one thing we have to think about is that this is a way of arranging the factors that might be responsible for a disease or a disease outbreak. And it's useful if there's a limited number of factors you want to consider. But obviously, it's not the same as a scientific model of disease, because it doesn't include how the factors fit together, and it doesn't enable you to make predictions about how to control the disease. So it's more like a checklist. So to sum up, person, place and time is historically a way that people have conceptualized the factors that might be relevant to an epidemiological inquiry into three important groups. And it can be useful if there's a limited number of factors that could be important, and you can do a search through each one of them exhaustively. I think the contrast would be with a systems science approach, where we try and put all the relevant factors into some sort of conceptual model to explain how they're going to work together, rather than listing them as three attributes of a triangle. And system science is coming later. So we're providing this because it has been influential in epidemiology. But there are now more integrated ways of thinking about how factors work together to cause disease, which we will come on to later. Thank you.